One of the problems that a lot of students had some difficulty with on the problem set is identifying how many monomers this polymer is made up of. So most people got the fact that this is an example of a polypeptide. And so let's take another look at a polypeptide that we saw in the lecture notes. So here's a polypeptide that has all of the atoms drawn out, and we can identify here a carboxy terminus or C terminus, the amino terminus or N terminus. The R groups are colored down below. And we could also see the peptide bonds, which attach the different amino acid residues to one another. And so we can kind of see that there are some repeating units that we can use to identify each amino acid on this illustration. We can apply those same logic to the problem set question. And so, for example, let's start at the RC terminus. And we could see that at the very C terminus, we've got our carboxyl group. Then we have a carbon that is attached to our R group. And then we have a nitrogen attached to a hydrogen, and then the peptide bond to the next amino acid residue. And so that next amino acid residue, we have a carbon double bond oxygen, carbon attached to the R group, and then a nitrogen attached to a hydrogen, and then another peptide bond. And then we have, again, repeating carbon, double bond oxygen, carbon attached to our R group, and then nitrogen, hydrogen. And then we'll do one more. We've got our carbon, double bond oxygen, carbon, R group, and then nitrogen attached to a hydrogen, and then a peptide bond, and then the next amino acid residue. And so we can actually apply that same logic when trying to identify how many amino acids make up this small polypeptide. And so let's see if we can do this. So first, let's start at our carboxy terminus, and we could circle that. So we have the carbon with the two oxygens. Then we've got our carbon with our R group. And this R group is going to define this particular amino acid as cysteine because it's got that sulfur on there. And then we've got our nitrogen, hydrogen. And then we go on to our next amino acid residue, where we've got our carbon, double bond oxygen, our carbon attached to the R group. The R group in this case is just a methyl group, and that's going to define this as alanine. And then we have our nitrogen, hydrogen. And then our next amino acid, we've got our carbon, oxygen. The carbon that with the R group is next, and so we can see that this R group is actually really a pretty large R group, and that's actually asparagine. And then we've got our amino terminus. And so we know, I think many students might have gotten confused because they kind of wanted to keep on going this way and counting additional amino acids in there. But that wouldn't actually make sense because the next atom that we expect to be bound to this carbon that's attached to the R group would have to be the amino terminus or nitrogen with a hydrogen on it, right? And so we can see that really the backbone has to be going this way because that's the only place where we see nitrogen, which is supposed to be the next atom of that backbone. I hope that this was helpful. I'll try to do other small videos on questions where people have, lots of problems.